Hello, welcome to another episode of this matrix operation programming. Today we're going to be taking a look at how to write program for inverse of a matrix. This time around the program is a little bit advanced because this time around we're not specifying whether we want the dimension to be 3 or what. This time around we're writing matrix inverse or inverse of matrix for n numbers, that is any number of dimensions. But the most important thing we have to bear in mind, it has to be square matrix. So without wasting time, because we have a lot of things to do, so let's quickly double click the inverse. Okay, we are inside the inverse coding area. And before we proceed, we need to understand that the method we are using is called Gauss-Jordan method. I will employ you to read over it so that you understand the essence of this programming. So let's quickly start by collecting the values that the user will input. So I'm going to dim n as integer. Then from there we can now quickly collect the value. N equals to input box. Enter the number of rows. You can call that one information. Okay. After that, let's quickly collect the value. So let's quickly dim the values we want to use to get it. I'm using AA. So I'm going to say AA input box brackets open. Enter S and I and J. Okay, so we have this one is going to be next J. Then we have next I. It's supposed to be AA. Okay, we've done with collecting. So the next thing is we are going to use the other method, which is that of the Gauss-Jordan method. So I'm going to say for the inversion, also redeem. We come here and say inversion into n, n times 2. So I'll just come here, copy this and paste. So here we said applying Gauss-Jordan. So we're gonna come here and change this value of AA to AJ, and I have to come here and declare AJ also. Okay, we've done that. So the next thing for us to do, okay, we've now corrected this. This one's supposed to be AJ equals to AA. So the next thing we're going to do is to commence the inversion process. So I'm going to use inversion begins. So we start by saying the first one for x equals to 1 to n. Then I'm using the matrix inverse to give me x, x plus n must be equal to 1. Okay, for y equal to 1 to n also, we have x comma y equals to AA x comma y. Now this equation will convert the equation to the ones of the matrix we need. Don't forget to put next y here, and here is going to be next x. So let's start another looping. We have for I equals to 1 to n. Now, we need to check if there's any value. That is, we need to place accepted value in two places. So if in case there's any issue, we have to go for the original one. So let me put it there so you understand. Place the accepted value in two places, just in case of row change. And how are we going to do that? We now say for W equals to 1 to n. Also, let's use J. For J equals to 1 to n times 2. So what should they do? I'll divide it into A and B. So before that, let me quickly do that of A and B, declaring A and B. It will be fast. This is A, this is B. I probably come here, Ctrl copy, Ctrl V. This is going to give me A. Okay, so let's go back to our coding. Here, I'm now going to say A into W, J equals to N, W, J. We do the same thing for B, so we separate the matrix into two. One is going to be acting as backup. Okay, we've done that. So what if any of the, don't forget to put this one is going to be J and this one is going to be W. What if diagonals are 0? Because we need to interchange the rows. So let's quickly place that one also. If that is A, I, equals to 0, then interchange the rows. And how do we intend to interchange the rows? So we now say if inv, that is I, equals to 0. And bear it in mind that your I is not equal to n. This is inv. Okay, so now say for x equals to 1 to I, for y equals to 1 to n times 2. This is where the division, that value we need, will now come in. It will now be inv into x, y equal to, remember we divided the a up there the other time. So it's now going to be a into x plus 1, y, and the other one, x plus 1, y, will now be equal to b, x, y. And that does the changing. So this one will be y, this one will be x, and we end the if. Now after ending the if, we quickly need to declare something. Let's quickly come up here and we need to get the value of that diagonal or that I at that point. So I'm going to quickly dim divide. Come here and say, let's call it divider. So I'll now come here and say divider equals to n v into I, I. Why is this not showing? Is it not the same thing we declared? Okay, we are redeeming instead of dimming. Okay, it's cleared. So let's continue. Don't forget, we're still looping from for I. This one is still there. So we're still working under it. So we now start our process here. Everything we've been doing since is just to check. So this is where the real inversion starts. So we now say for j equals to 1 to n times 2. if j equals to I, then go to 100, and if. I'm going to show you where I'll place the 100 to do the checking. I just placed that one there. Then place, I need to declare place also, equals to inv j comma I. Then let's start the processing in between. Now say for z equals to 1 to n times 2 inv into j comma z equal to v minus place times, but this time around this one is going to be I comma z. Don't forget it's going to be next z. Then we have the next j. Okay, so I'm placing this. This is where my 100 comes in. So we're through with the operation. The next thing we're going to do is to display our results. So let's quickly go to this side and copy some values. I'm going to come to this place and copy some of the values. Put to display results. Okay, so let's do the outputs together. And that reminds me, before we do the outputs, we need to bring it to n by n value that it requires. For j equals to 1 to n, I want to dim AB, then come here and redeem AB as n by n. Okay, so let's go back to this place and say AB I comma j will now be equal to nv I comma j plus n. So good. So to display the results, we now first display what the user entered, I to n. I'm going to call, before that one, let me quickly copy this, paste it here, and another one paste. The first one is for cleaning, make everything there empty. Then the second one is to display what we're doing, which is inverse of matrix. Then the products you entered first that we didn't tamper with, which is AJ. That is the value we didn't tamper with, because if you check, we made use of A here, but let's make use of AH, which is the permanent one we didn't tamper with. So we come here and say AJ. That will display the original matrix, or let me use the word original matrix here. Then we now come and say inverse of matrix. Now the inverse of matrix is also going to be according to n that we've entered, also n that we have entered. Then our display is going to be the value from here where we separated it, which is AB. I think that is it. So let's try and run it. Don't forget to save. Okay, it has loaded. So let's click inverse. Let's start by 3 by 3 matrix. I'm going to enter true. It's asking me for value. Let's say this is 2, this is 1, this is 0, let this one be 1, 2, 1, 0, 1, and 2. Beautiful. Now look at our original matrix we entered. Then this is the inverse of the matrix. So you can equally use Excel to check. So what I intend to do now is to walk you through the program again, so it won't look as if we've made mistake. Let me quickly start from this point. Look at all our declarations. We applied the Gauss-Jordan. We've applied the inversion, begin here. We also placed, in case we have a rule that we need to change, this is where the rules are being changed, and follow up to this area, and it ends here. And this is the code for inverse of matrix. Remember to save your work. And next time, we move to another interesting topic. Thank you for watching.